Imagine a world where humans live at the Planck scale, a realm so minuscule that a Planck length is approximately 10 to the power 24 times smaller than the size of an atom. This shift in perspective would lead to an existence beyond our wildest imaginations and scientific understanding. The Planck scale, named after the pioneering physicist Max Planck, represents the threshold where our classical notions of gravity and spacetime break down and quantum effects reign supreme. Venturing into this realm challenges our current grasp of physics, biology, and even philosophy. Living at the Planck scale is a profoundly speculative idea, pushing us to envision entirely new forms of existence, communication, and technology. It also prompts us to consider unprecedented societal structures and ethical dilemmas. This concept invites us to expand the boundaries of human imagination and scientific inquiry, urging us to rethink the very essence of reality and our place within it. The Planck length represents a boundary where our conventional understanding of physics begins to break down, giving way to the strange and wondrous laws of quantum mechanics. In this minuscule domain, the smooth continuum of spacetime that we take for granted ceases to exist. Instead, spacetime is thought to be a chaotic and frothy landscape, often described as quantum foam. Here, particles pop in and out of existence, and distances blur into a haze of probabilities. It's a world where the concept of a definite location becomes meaningless, challenging our very perceptions of reality. Understanding the Planck scale is crucial for physicists because it's believed to hold the key to unifying the forces of nature. At this scale, the effects of quantum mechanics and general relativity, the two pillars of modern physics, are equally dominant. The pursuit of a theory that harmonizes these forces, known as quantum gravity, could revolutionize our understanding of the universe. As we explore deeper into this mysterious realm, let's set aside our everyday notions of space, time, and matter.
Quantum physics governs particles at the smallest scales, especially at the Planck length. Here, the Heisenberg uncertainty principle makes precise measurement impossible. This unpredictability defies classical mechanics. Gravity becomes a quantum force. Quantum gravity suggests spacetime is granular, unlike Einstein's smooth fields. This impacts our understanding of black holes, the Big Bang, and reality. Spacetime foam, proposed by John Wheeler, is turbulent at small scales. Tiny wormholes might connect distant regions, allowing quantum teleportation. Exploring the Planck scale challenges paradigms and opens technological advancements. Quantum computing relies on superposition and entanglement, key to quantum foam. Understanding quantum physics at the Planck scale has transformative potential.
At the Planck scale, classical physics unravels. Newtonian mechanics cease to apply. Uncertainty and probability take center stage. The Heisenberg uncertainty principle dictates unpredictability. Spacetime becomes a frothy, turbulent quantum foam. This challenges our understanding of reality.
At the Planck scale, gravity becomes a quantum force intertwined with fundamental particles. This field, full of revolutionary potential, suggests spacetime is composed of tiny, indivisible units. String theory posits that the universe's constituents are tiny, vibrating strings. Loop quantum gravity proposes spacetime has a granular structure made of tiny loops. Exploring quantum gravity could reveal insights into black holes and the universe's origins.
Spacetime foam, a chaotic landscape. Coined by John Wheeler, spacetime foam is a chaotic, fluctuating landscape. Here, the smooth fabric of spacetime is a frothy mixture of quantum events. Traditional physics is challenged by this turbulent environment. Particles appear and disappear, making positions uncertain. Tiny wormholes and black holes form and evaporate instantly. Quantum entanglement could be facilitated by this interconnected foam. This has profound implications for quantum computing and cryptography. Studying spacetime foam could reveal the fundamental nature of reality. This chaotic landscape reminds us of the infinite complexity of the microverse. Section 4. Implications for modern science. The exploration of the Planck scale has far-reaching implications for modern science. It challenges our understanding of the universe, pushing us to develop new theories and technologies. These advancements could revolutionize multiple fields, from theoretical physics to practical applications. One significant implication is the potential for a unified theory of quantum gravity. This theory could provide answers to profound questions in physics. Advancements in understanding quantum gravity could also lead to new technologies. Quantum computing relies on principles integral to the behavior of particles at the Planck scale. Mastering these principles could create computers with immense processing power. The study of space-time foam and quantum fluctuations could pave the way for new forms of communication. Quantum entanglement could enable instantaneous communication across vast distances. This could revolutionize fields such as cryptography and global communications. The implications of Planck-scale physics challenge our philosophical views, prompting us to reconsider the nature of reality. Redefining biological structures. In the quantum realm, traditional biological structures cease to apply. Life forms would need to be composed of fundamental particles behaving according to quantum laws. The building blocks might be quarks, leptons, and perhaps even strings. These particles, governed by quantum mechanics, form new kinds of biological structures. Organisms would exhibit a fluid and ever-changing morphology. This fluidity might give rise to rapid transformation and adaptation. Life at the Planck scale challenges our basic assumptions about biology.
At the Planck scale, traditional chemical reactions become irrelevant. Instead, quantum states and entanglement dominate, creating a new form of chemistry. Chemical bonds are replaced by dynamic assemblies of particles in multiple states. Energy transfer occurs instantaneously through quantum effects, leading to rapid transformations. This quantum chemistry suggests life would be fundamentally different in structure and function. Exploring these interactions could reveal new scientific and technological possibilities.
Energy management at the Planck scale requires new mechanisms. Quantum tunneling and zero-point energy become vital for sustaining life. Metabolic processes involve simultaneous and interconnected reactions. Energy storage might involve maintaining specific quantum states. This suggests life could operate with unprecedented efficiency and adaptability. Exploring these concepts challenges our understanding of energy and metabolism. Perception in the quantum realms involves direct interaction with quantum states. Entities perceive a probabilistic web of quantum events. Cognition might involve quantum computation for rapid processing. Communication could occur through manipulation of quantum states. This suggests life would experience reality in ways alien to us. Exploring these concepts enriches our understanding of consciousness and perception.
Living at the Planck scale transforms sensory perception. Perception involves sensing the probabilistic nature of particles. Entities detect quantum states and observe superpositions. This leads to a dynamic way of interacting with the environment. Quantum sensory perception redefines our understanding of sensory experience. Traditional senses give way to quantum interactions.
Cognition at the Planck scale requires quantum computation. Entities process quantum information rapidly. This enables decisions and responses with unprecedented speed. Quantum cognition might involve collective intelligence through entanglement. This represents a fundamental change in the nature of intelligence. Exploring these concepts pushes the boundaries of conscious beings.
Quantum entanglement enables instantaneous communication. Messages are transmitted instantly, ensuring real-time connectivity. This method is highly secure and allows for complex messages. Quantum communication conveys vast amounts of information. This suggests a future where distance and time are no barriers. Exploring these concepts challenges current technological paradigms.
Quantum perception alters concepts of individuality and reality. Interconnected quantum states suggest a collective existence. The probabilistic nature of the quantum realm raises questions about reality. Cognition involving quantum states redefines consciousness. This exploration enriches our philosophical perspectives. Understanding the quantum realm transforms our view of the universe.
Societal constructs reflect quantum mechanics principles. Hierarchies are replaced by networks of entangled entities. Societies function like living organisms with collective consciousness. Governance is decentralized and efficient through quantum computation. Cultural practices evolve with probabilistic interactions. Exploring these structures offers insights into dynamic social organization.
In the quantum realms, communication would transcend the limitations of classical methods, relying instead on the principles of quantum mechanics. Quantum entanglement would serve as the cornerstone of these new communication networks, enabling instantaneous and secure information transfer across any distance. Quantum communication networks would operate through entangled particles, where the state of one particle directly influences the state of another, regardless of the physical separation between them. This phenomenon, known as quantum teleportation, would allow for real-time communication without the need for physical transmission of signals. This could revolutionize the way information is exchanged, creating a seamless and instantaneous network of connected entities. The security of quantum communication networks would be unparalleled. Any attempt to intercept or alter the communication would immediately disrupt the entangled states, alerting the parties involved to the breach. This would ensure the integrity and confidentiality of the transmitted information, making quantum communication networks ideal for sensitive and critical exchanges. Additionally, the richness of quantum states would enable the encoding of complex and nuanced messages. Unlike classical binary systems, quantum communication could convey vast amounts of information through superposition and entanglement, leading to efficient and sophisticated forms of interaction. This would allow for a depth of communication and understanding that is currently unattainable with traditional methods. The development of quantum communication networks would not only enhance the connectivity of quantum societies, but also offer new possibilities for secure and efficient information exchange in our macroscopic world. This exploration challenges our current technological paradigms and opens up new avenues for innovation and advancement. Governance in quantum societies would need to reflect the unique challenges and opportunities presented by the quantum realm. Traditional forms of governance, based on hierarchical structures and fixed laws, would be impractical in this dynamic and interconnected environment. Instead, governance might be based on principles of quantum coherence and superposition, with laws and regulations designed to optimize the stability and functionality of the quantum society. In such societies, decision-making processes could involve collective quantum computation, where the entire community participates in reaching consensus. This could lead to a highly democratic and decentralized form of governance, where every entity's quantum state influences the outcome. Such a system would be adaptive and responsive, capable of evolving in real time to meet the needs and challenges of the society. Ethics in quantum societies would also require rethinking. The interconnected nature of quantum states suggests that actions and decisions could have far-reaching and immediate consequences. This would necessitate a more holistic and interconnected ethical framework, focusing on the well-being and coherence of the entire society, rather than individual autonomy. The manipulation of quantum states and the potential for profound influence over the environment and other entities raise significant ethical considerations. Ensuring the responsible and equitable use of such power would be crucial, requiring robust ethical guidelines and oversight. This could lead to the development of new ethical principles that prioritize balance, harmony, and the collective good. The exploration of governance and ethics in quantum societies not only provides insights into the potential for more responsive and inclusive forms of social organization, but also challenges us to rethink our own ethical frameworks. This investigation highlights the importance of adaptability, cooperation, and responsibility in navigating the complexities of the quantum realm. The transition to living at the Planck scale brings profound philosophical shifts, altering our understanding of existence and reality. Quantum mechanics principles like superposition and entanglement redefine these concepts, leading to a more interconnected view of life. Individuality might dissolve into a collective identity, part of a larger interconnected whole. This challenges traditional views of autonomy, promoting a holistic understanding of existence. Boundaries between self and other blur, fostering unity and interdependence. As we conclude our journey into the enigmatic realm of the Planck scale, we reflect on its profound implications. Life at the Planck scale presents a radically different view of existence, challenging our fundamental assumptions about reality. Quantum gravity and space-time foam reveal a universe where certainty is replaced by probability. The fabric of reality is a dynamic interplay of quantum events, opening new possibilities for understanding our cosmos. Biologically, the Planck scale redefines the building blocks of life. Traditional atoms give way to fundamental particles and quantum interactions, leading to fluid, adaptable life forms. This shift necessitates new forms of energy management and cognitive processes, showcasing life's adaptability. Perception and cognition in this quantum world are transformative. Entities interact with their environment through direct engagement with quantum states, experiencing a probabilistic reality. This suggests that awareness might be a quantum phenomenon, intertwined with the universe's fabric. Societal structures in the quantum realm reflect the dynamic nature of quantum mechanics. Fluid networks of entangled entities would replace traditional hierarchies. Quantum communication networks would revolutionize interaction and cooperation. The philosophical implications of life at the Planck scale are profound. The fluidity of reality and potential quantum nature of consciousness invite us to rethink our existential views. This exploration expands our scientific horizons and enriches our understanding of existence. Reflecting on this journey, we are reminded of the boundless potential of human curiosity and imagination. By exploring the Planck scale, we push the boundaries of knowledge, uncovering new insights into reality. This thought experiment challenges us to envision a universe where the unimaginable becomes possible. As we probe the mysteries of the cosmos, let us embrace the infinite complexity and beauty of the quantum realm. Through this exploration, we gain a deeper appreciation for the interconnected web of existence and our role within it.